Next, let's look at the critical ratio scheduling. We talked about this briefly before. Now, critical ratio looks at not just the time remaining at a given workstation, but it takes a longer look. So here is the formula for critical ratio. CR is critical ratio, is given by time remaining divided by work days remaining. In other words, the processing time. So that is another way of looking at it is job due date or days till due date. That is how much time is there till due date, and then processing time remaining. How much processing time is yet to be completed. So let's take a look at what the CR means for just a second. Now, if you have more work than the amount of time available, suppose if you have due date is 10 days, but the amount of processing time needed is 20 days. So then this will be 10 over 20, you will get 0.5. So if you have processing time remaining is also 10, then you'll get 10 over 10 is 1. So 1 and anything smaller than 1 means the job is critical, because the best you could do is to meet the deadline, and any problems, then you're going to miss the deadline. On the other hand, if you have more time remaining than processing time, so you have time till due date is 10 days, but amount of processing time remaining is say 5 days. So 10 over 5 will be 2. So any value larger than 1 means there is some cushion available. So smaller the value of CR, the more critical the job is. So when you compute CR, then you need to arrange the jobs in the order of, in increasing order of CR. The smallest CR is the most critical, so that should go first, and then the next smaller one, and then the next smaller one, and so on. Okay, now let's first compute the value of CR, and for that let's go back to the beginning of the problem. So here is where we started, and here I have a column for CR. So we're going to compute the CR first, and remember CR is time remaining divided by the processing time. So this will be 50 over 20, so gives you 2.5, and then 70 over 30 gives you 2.33, 45 over 10 gives you 4.5, then 100 over 16 gives you 6.25, then 80 over 18 gives you 4.44. So now we have to arrange the jobs according to CR. So let's do that now. So the smallest CR goes first, so that will be B. CR is 2.33, and then the next one is A with 2.5, and the next one is E with 4.44, and 4.5 is next, and then finally D, and that is 6.25. So that's our CR. Now let's get the processing time and the delivery due date entered here. So for processing time for B is 30, 20, 18, 10 and 16, and the job due date time remaining is 70, 50, 80, 45 and 100. Now we can compute the completion time, which is 0 plus 30 is 30, 30 plus 20 is 50, 50 plus 18 is 68, 68 plus 10 is 78, 78 plus 16 is 94. Now lateness here is 30 is before 70, 50 is okay too, 68 is before 80. So here we have 78 minus 45 is 33, 94 is before 100 is 0. Now let's compute the measures. So we need the sum of this, which is 320. So 320 over 5 is 64, and this sum is 33. So 33 over 5 is 6.6. Now we need the sum of processing time, which is 94. So 320 over 94 is 3.4. Then utilization is 94 over 320 times 100 gives you 29%. Okay, now let's put all of them here for comparison. So SPT is 47.6, 7.6, 2.532 and 39.5%. EDD is 54, 0, 2.894, 34.6%, and CR is that 64, 6.6, 3.4 and 29%. Now you see the first three, actually the first one is the measure for WIP, and that SPT gives you the smallest value, and similarly average number of jobs in the system, that's also a measure of work in process inventory. So SPT gives you the minimum value. The utilization is not precisely work in process inventory, it is about the percentage of time a job will not be idling, and that the smallest value is CR. Now, as far as the delivery due date performance is concerned, EDD gives you the best value, and this is what we discussed earlier also.